to this computer. All right, guys. So today what we're going to be doing is looking at determining the bounded region of an area. So this is very similar to what we did yesterday, except for we don't have a graph to look at. So really the easiest way to do this is not the only way to do this, but I would say that definitely the easiest way to do this is to take these equations. Hold on a second, let me make sure I got this. And to plug them into Desmos or your graphing calculator and actually visually see the bounded regions. And so I already have Desmos popped up here. And I'll try to zoom this in a little bit, but I'll have to zoom that out. Okay, so here's the first question. We have this bounded region here. This is a graph. So we have this kind of curvy line here. And then we have this x equals 2, which is a vertical line. And then we have y equals 0, which is kind of hard to see, but that is the x-axis. So what we want to do is find this region that's in between those three lines. So it's kind of this like really curved, steep slope area here. Well, if we remember, integrals can find the area underneath the curve, and luckily, and this is what it will always be in this section here, this line here, the y equals x cubed plus 3 is the top of the curve. No matter where we look, it's always the top until it reaches that point, which gets stopped. So since that is always the top of the curve, that can be our integral that we find the area underneath. The other thing that's really nice is that we use the x-axis, y equals 0, which is what the integral revolves around. So we can actually set this up as an integral, and I'm just going to show you on Desmos. You can do the same thing on there too. Desmos can evaluate definite integrals. If we click the keypad here, and there is a choice in functions, we all have to go over to miscellaneous. You'll see a little integral button. So I'm going to zoom that up a little bit bigger so we can see. So all we need to know is the integral. What is the start? What's the finish? And then what's the equation? Oh, I'm trying to pop that down a little bit. Okay, so the start of it, if we look at our graph, would start at 0. And this goes all the way over to 2. That's where the blue line is at. And then what is our equation? What's the top of the curve? And the top of the curve is this x cubed plus x. So I'm going to just type that in, x cubed plus x. Now, I'm not sure if I need to press dx or not on Desmos. We'll find out. I think so, dx. No, just press enter. No, what's going on? Desmos, you were working fine a second ago. All right, let's scroll this down. Maybe I got to put it in parentheses. Okay, well, let me try something else. I'm going to change this to this y equals. I'm going to change this to f of x. I know this trick will work. No, dx. There we go. Okay, had to do a little trick here. So the Desmos is a little particular. That's why I like the graphing calculator a little bit easier. But if we change this top function to f of x and just say we're going to integrate from 0 to 2 of f of x dx, it tells us the answer. So the graphing calculator is a little nicer. We'll shade it in and we'll show you. But just so you can do the same thing on Desmos. It's just a little bit tricky. So the first problem should be 6. Let's hope that's right. We'll find out. Okay, the next problem here, which I actually have set up as Desmos. We have the equation here, 2 radical x minus x, and then we have just one equation, which is the x-axis, the y equals 0. So we can see we can have a bounded region just by 2 graphs. We just need to know like where does it start, which is at 0, and then where does it stop, which would be at 4. So if we were going to do the integral, we'd take out the integral function here. I'm going to do this the right way the first time. Our starting point is at 0. This is where the graphs first touch. And then the next point where they touch is 4. And then what is the equation that it's bounded under? So I'm going to change this one to f of x, just to make Desmos work a little bit better. F of x dx. And it will tell us the answer here. 2.6667 if we round it in. 2.6667. Okay, so what we're doing here is just taking the integral. We could do it the long way, but making the calculator a little bit better, or using the calculator can make these things a whole lot better. Okay, one last problem here. We got y equals 1 minus x to the fourth and y equals 0, so very similar to the last one. If we type it in Desmos, we get this graph here. We have the y, or now the 1 minus x to the fourth. Gee, let's try that again. Y equals 1 minus x to the fourth, and then we have y equals 0, which is the x-axis. So we can see this one starts at -1, goes over to +1. So if we're going to do the integral, which we can do on Desmos, even though it's not fun, we can still do it. On here, come on, click that. Our lower limit is -1, because that's where it first touches. Our upper limit is +1. And then what I'm going to do is just type in or change this to f of x. So I guess this is the only way Desmos knows how to work. I probably could use y, but I think it might not know which one is y. dx. And we get 1.6, which says round to the fourth decimal, but I'm going to put 1.6. It probably will automatically type in zeros for me. We'll find out. I'm going to submit the quiz. How do we do? Fingers crossed. 4 out of 4. Okay. So any questions there?
So if you have the values, so like in question 1, if you have both of the values x and y, then you don't really need to put it on the graph. But
not necessarily, because hypothetically, this graph doesn't, like, I mean, this equation does start at 0, 0. It could potentially start over at -2 and curve all the way up and then meet at 2. So we have to look to see where it crosses the y equals 0, which is at 0. And then where does it cross the x equals 2, which is at 2.
Okay, so with these, like, we need to graph pretty much every one of them.
Yeah. What gets more complicated, I'm going to mess around with something. Sometimes you could have graphs, like say we could have another one that like curves up and over and around. Actually, not around like that, but we could have graphs that like weave in and out of each other. That's a section in the chapter that we normally go over, but with everything going on, what we would have to do is like split it up and be like, okay, we're going to find the area underneath this curve from here to here, and then find the area underneath this one from here to here and add those two areas together. But I just try to keep the easiest ones on here. So you got to graph them to really actually see any of them if they work.
Okay.
Yep. Okay. Well, I'm gonna close. Oh, whatever. Okay. Now that's on my screen. Okay, whatever. So tomorrow, what are we doing tomorrow? Let's take a look. Ooh, mean value theorem. So tomorrow's going to be something new, different. It's going to be what we've been doing, just an extra step further. So it'd be a good one to check into. And this one, we cannot just plug straight into the calculator. We'll plug a lot of it into the calculator, then we have to do an extra step. Okay. We good there?
Yep, sounds good.
All right. Short and simple. All right. Have a great one.
Thanks, you too. Bye.
Bye.